Have you ever wondered about the importance of limit calculus in our daily lives? Welcome to the intriguing world of limit calculus, a dimension of mathematics that's as fascinating as it is vital. At its core, limit calculus is a fundamental concept that injects life into the heart of calculus theory. It plays an essential role in determining derivatives and integrals, shaping the bedrock for our understanding of the mathematical universe. But that's just the tip of the iceberg. The power of limit calculus extends beyond pure mathematics, reaching into the realms of physics, engineering, economics, statistics, and so much more. It helps us model complex phenomena, solve intricate problems, and make sense of the world around us. And it's not just about finite limits. We'll also dive into the realm of infinite limits, exploring how they describe extreme behaviors in mathematics and real-world situations. So, buckle up as we embark on this fascinating journey of exploring the world of limit calculus. Scene script. Imagine trying to build a house without a foundation. Impossible, right? That's how crucial limit calculus is to the entire structure of calculus. Much like a foundation supports a house, limit calculus provides the underpinning for all of calculus. It's the cornerstone upon which the grand edifice of calculus is built. When we delve into the realm of calculus, we're stepping into a mathematical world that revolves around change and motion. And it's here that limit calculus shines, helping us make sense of these complex concepts. Consider derivatives, for instance, the mathematical tools that help us understand rates of change. Whether it's a car accelerating down a highway, or a population of bacteria growing in a petri dish, derivatives give us a way to describe these changes precisely. And the way we define a derivative? You guessed it, through the concept of limits. And then there are integrals, the flip side of the calculus coin. Where derivatives break things apart, integrals piece them back together. They help us accumulate quantities, find areas under curves, calculate volumes, and so much more. And at the heart of defining an integral, there lies limit calculus again, quietly doing its indispensable work. But limit calculus isn't just about the nuts and bolts of calculus, it's also about giving us a way to deal with the infinite and the infinitesimal, two concepts that are mind-bogglingly abstract, yet incredibly useful. By grappling with these, limit calculus allows us to push the boundaries of what's achievable with calculus, enabling us to solve problems that would be otherwise out of reach. In essence, limit calculus is the unsung hero of calculus. It's quietly at work in the background, making possible all the remarkable things that calculus can do. It's the silent heartbeat that keeps the lifeblood of calculus flowing. Without limit calculus, we wouldn't have the mathematical tools to understand the world as we do. Ever seen a rocket shooting towards the sky? That's an example of an asymptotic function, and limit calculus helps us understand these. Asymptotic functions have something called asymptotes, invisible lines that the function approaches but never quite reaches, much like a rocket shooting towards the infinite sky. Picture a curve on a graph that gets closer and closer to a line without ever touching it. That's an asymptote. Now, limit calculus steps in to make sense of this. It helps us understand the behavior of these functions at these critical points. We use limits to examine what happens as we approach these asymptotes, both horizontally and vertically. This analysis reveals fascinating insights about the function's behavior and can help predict outcomes in various fields, from physics to finance. Without limit calculus, we would be left scratching our heads at these fascinating asymptotic functions. From the tallest skyscrapers to the smallest microchips, limit calculus is everywhere in the world of physics and engineering. Let's delve into the fascinating realm of physics first. You see, in physics, limit calculus enables us to understand and predict the behavior of moving objects. Think about the concept of instantaneous velocity. When an object is in motion, its velocity might change from moment to moment. So, how fast is it moving at a specific instant? This is where limit calculus steps in. By calculating the limit of the average velocity over an increasingly short time interval, we arrive at the concept of instantaneous velocity. This concept forms the backbone of Newton's laws of motion and is essential for understanding the world around us. But that's not all. Limit calculus is also fundamental to the study of electricity and magnetism. It helps us calculate electric and magnetic fields, which are crucial for designing everything from power generators to MRI machines. Without limit calculus, we wouldn't be able to accurately model or predict these phenomena, and our technological advancements would come to a standstill. Now let's turn our attention to the engineering world. In engineering, limit calculus is used to model and analyze systems. It allows engineers to calculate rates of change and understand how different variables affect the behavior of a system. For instance, in civil engineering, limit calculus is used to calculate stress and strain in materials. This enables engineers to design structures that are both safe and efficient. Similarly, in electrical engineering, it's used to analyze circuit behavior, allowing for the creation of everything from smartphones to electric cars. In essence, limit calculus is a powerful tool that helps us navigate the complexities of the physical world. It's a language that translates abstract concepts into concrete realities, allowing us to engineer marvels that shape our everyday lives. Next time you marvel at a technological wonder, remember, limit calculus played a part in its creation. Infinity is a concept that can boggle the mind, but limit calculus helps us make sense of it. Now let's dive into the captivating world of infinite limits. Infinite limits are, in essence, mathematical expressions that describe what happens to functions as they approach infinity or negative infinity. They are a way of saying, hey, this function keeps growing or shrinking without any bounds. But how does this apply to the world around us? Well, consider a black hole, one of the most extreme phenomena in the universe. As an object gets closer to the event horizon, the gravitational pull becomes stronger and stronger, approaching infinity. The function describing this pull is an example of an infinite limit at work. Infinite limits also help us understand the behavior of functions around critical points like vertical asymptotes. These are points where the function shoots off to infinity or dives down to negative infinity. They may seem like mathematical oddities, but they are key to understanding many mathematical and scientific phenomena. For instance, in the field of engineering, infinite limits can help us understand the behavior of certain materials under extreme pressure, or the propagation of light through a medium. They can even help us predict how a structure might behave under severe load conditions. In economics, infinite limits come into play when considering exponential growth or decay. Consider the concept of compound interest. The function describing the growth of an investment over time can shoot off towards infinity, given enough time and a high enough interest rate. So you see, infinite limits are not just abstract mathematical concepts. They are tools that help us understand, predict, and describe the extreme behaviors we encounter in the universe, from the behavior of black holes to the growth of our investments. With limit calculus, even infinity becomes a concept we can grapple with. Through these mathematical tools, we can explore the infinite, understand the asymptotic, and make sense of the seemingly incomprehensible. So keep diving into the intriguing world of limits, and let's continue to explore the infinite together. As we reach the end of our journey, it's clear that limit calculus is not just a mathematical concept, but a tool we use to understand the world around us. In a broad sense, limit calculus forms the backbone of calculus, a branch of mathematics that studies rates of change. It is fundamental in determining derivatives and integrals, and is instrumental in understanding the behavior of functions at critical points, such as vertical and horizontal asymptotes. Delving further, we see the profound influence of limit calculus in various scientific disciplines like physics and engineering, where it aids in solving complex problems and modeling intricate phenomena. It's fascinating to imagine how this seemingly abstract concept is used in the construction of bridges, the design of aircraft, and even the exploration of space. In the realm of continuous functions, limits play a pivotal role. By defining the continuity of functions, they provide a foundation for mathematical analysis. This concept has far-reaching implications, extending beyond the classroom and into the real world. And who could forget the concept of infinite limits? These are the tools that allow us to describe extreme behaviors in mathematics and real-world situations alike. They push the boundaries of our understanding and invite us to explore the infinite. The applications of limit calculus permeate various fields, even economics and statistics, where it is used in economic analysis, data modeling, and the formulation of fundamental theorems, such as the central limit theorem. In the sphere of numerical calculus, limit calculus is a trusted ally, assisting us in approximating values and making complex computational tasks manageable. But the world of limit calculus is not without its challenges. Indeterminate limits present a conundrum that mathematicians are constantly seeking ways to resolve. It's an area rife with ongoing research and open questions, a testament to the dynamism and intrigue of this field. So, the next time you see a complex mathematical equation or a stunning piece of technology, remember the role of limit calculus in shaping our understanding and our world.